So I'm going to talk about research that I've been working on with respect to code generation from natural language input. The whole task here is about improving programmer productivity, and there's been lots of efforts over the years for ways to improve the results of a programmer. Several people have tried natural language programming, and it always sounds promising, but there always is some challenges associated with it, and I'm going to talk about how we've approached that. And at the end, I'll talk and how this compares to some of the things that are going on in the large language model world, and how how they relate. So to address this problem, we created a programming tool approach, which we call Cabernet, with the following goals. First of all, we wanted to increase the productivity. We wanted the approach to be flexible and be very straightforward in the syntax, but give the programmer or developer control over the resulting application. And to the extent that was possible, to make it English-like, so a subset of English or a specific way of using English. And the idea is to address the needs of a wide range of programmers, working on the learning curve for a novice programmer, making the program readable and easy to understand for the experienced programmer, and simplification for the possibility of end user programming. The basic approach is declarative in nature. And it is, as I said, a natural language, which improves the flexibility and makes it more forgiving. And we use inference to fill in the gaps where the natural language is incomplete or vague. And the end goal is, can we create a controlled natural language release programming tool that's readable, flexible, extensible, and easy to learn? And so Cabernet is based on Markdown, which is a technique that was originally created to simplify the creation of HTML. It is outline-based. It is very terse, and the nomenclature is flexible, and we use synonyms and a thesaurus to take a variety of inputs and get a understandable output. And each bullet is limited in context. As you can see over here on the right, things can be as simple as a adjective describing what the field on the screen it looks like, what the background and foreground color is, what the content is, and what the function is. The initial approach was applied to iOS-based applications, and so we've narrowed the context that we're trying to address, and so you can make assumptions based on that. And because it's based on Markdown, and Markdown is intended to be used to generate HTML, we can compile the Markdown to HTML and then use cascading style sheet to improve the readability. So you have the Markdown based text here, which is somewhat confusing perhaps with all the code, the symbols, but if you compile it back to HTML and use a cascading style sheet, you can make it very visually attractive. And then, as I said, we use a thesaurus as a way of equating alternate nomenclatures. So things like an application name, the user can call it an app, an application, a program. Screens can be referred to as scenes or windows or screens. And we can use a thesaurus to even fill these in with other alternatives, or for customizing for a particular developer or developing team, you can even manually add additional words or phrases here to describe these various types of objects. So as a high-level approach, as traditional programming languages are imperative. It describes what to do. It tells you how to build the house. But the tendency, and particularly in the case of iOS applications, SwiftUI has gone to declarative, describing the end results. Don't tell me how to build a house. Tell me what you want the house to look like. And Cabernet is declarative with a difference. It's natural language based, and it uses inference to discern the programmer's intent. And because then we use templates and defaults to generate the actual resulting program, you can be very simple in your explanations. Each bullet contains a single context. It encourages terse input. It might just be an adjective, like, for example, a field might be green or italics, or describe the width of a field. Objects which require evaluation would have simply a math statement, for example, or a search statement, but not combining information in a given bullet. And we can infer from the nature of the statement. So if you have a math statement, that's a math statement. But if you're not sure, you test that assumption and either default to text, or you ask the programmer to further explain their desire. And then as we feed back the final result to the programmer for their evaluation. So when we get to the point of something like a math statement, we allow a wide range of possible inputs. So you could have a simple formula, or you could have some combination of English and/or mathematical formulas to get to your result. But then we tokenize those statements, and then we use a natural language interpretation to come up with a formula that the computer can deal with. And we just use discovery. So we say, okay, here's a math statement that says I want the bill amount. Well, is there something on the screen or in the application that's called bill amount? And then I can use that as part of the input to my formula. If I can't find that, then I ask the programmers, what did you mean here? Or is this in fact a math statement? So as I said, we start off with Cabernet, which is written in Markdown. We tokenize that and take in each individual item. We look for synonyms. Is this a screen or a scene, or is this a field? And then we use inference to fill in the missing tokens, or to clarify the missing tokens, and then identify each object by some context, test the accuracy. Does this all make sense when I get done? Then we simplify it using natural language tools, generate target code. So, we would, if you take a Cabernet-based input, you then convert it into a Swift program, which is then compiled and run on the target platform. And a given Cabernet input can be targeted at a variety of end applications. So take Cabernet, we tokenize it, but then we can convert it to SwiftUI, Swift, or Android, and then run it on the end target. So one of the things that was the goal was to make the program simpler or more concise. And in fact, here is a simple volume calculator that takes Cabernet 15 lines to describe, and Swift for the same application is 133 lines of code, and obviously much more readable. So if you look here at the Cabernet on the left here, and then this is the first 31 lines of the Swift program to do the same thing. Or SwiftUI, because it is declarative in nature, makes it more succinct than Swift, but still takes 76 lines to get this same program. And here's the program. This Cabernet program here gives you this application over here. So we have some relatively straightforward examples here. We have a tip calculator. We have a real estate application, storing information about a real estate a lot being sold, how much area is it, what's the price, what the address of it is, and then we have a third application where we have some things about the input fields that are modified based on what the information provided is. And Cabernet, range from 14 to 30 lines of code here, whereas Swift, was up to 211 lines of code, and SwiftUI for the same applications is around 100 lines of code. So 4 to 7 times as much code to get the same thing accomplished. And then error checking. So how do you make this more foolproof? Well, because we're not telling you how to do things, we're telling you what you want the end result to be. Common errors are easy to check for. So things like don't divide by 0. If I expect a number as an input for a calculation, don't give me a string. And then never refer to uninitialized variable. All these things are incorporated into the templates. They're standard error checking procedures that programmers use. But because I'm not telling you how to do things, I'm just telling you what the result I want. The templates themselves can handle those kinds of error checking. We see the opportunity to learn here. So obviously we talked about the Thesaurus and other ways of expanding its understanding of the user's input, but then we continue to expand based on the APIs for the target result. You can add to this capability, and then using techniques like looking through industry documentation, you can add additional algorithms. So the main question we asked is, how easy is this to understand? The people who have never been exposed to it with no documentation, do they understand what it means? What the programs mean, and would they be able to utilize the tool? And so we took a survey of 47 graduate and undergraduate students in computer science, so people who have some computer background from DePaul and Virginia Tech, and they self-identified experience level. 31 said they were a student, 7 identified themselves as developer, and 33 reported 3 or more years of experience, and 6 with 2 or fewer years of experience. And we asked them a series of questions. We gave them the 3 sample programs. We provided them with screenshots, and then we provided them with the source code in Cabernet, Swift, and SwiftUI to create the same applications. And then we asked them 35 questions about their ability to understand the programs. And so how easy was it to understand? So they graded each of the questions on a scale of 0 to 10 with respect to things like how easy it is to understand. And of the questions that were associated with easy to understand, 80% of the answers graded Cabernet 7 or higher on easy to understand, whereas the same programs in Swift and SwiftUI were down around 5 to 6. And then we said, okay, so you think this is easy to understand. How confident are you that you have understood it? Okay, I think this is easy to understand, but how confident am I that my interpretation of what I've been shown makes sense? And once again, Cabernet came out ahead, about 6 3/4 on average, versus 5.8 and 6.3 for Swift and SwiftUI, and ranking Cabernet 7 or higher 61% of the time, whereas Swift and SwiftUI were only 7 or higher 40 and 53% of the time. And in general, we asked the users for their feedback about the programs and the tools. And basically they all found Cabernet easy to understand, but because it's a natural language, because it lacked some structure, they had some concerns about making sure they understood what the result they were going to get for their input. So as I said, they found it easy to understand. They were concerned about the granularity of the control. Okay, if I wanted to do this specific thing, how do I make sure it does that? And in general, they suggested that Cabernet may be better suited for end user programming or perhaps rapid prototyping. Talking about comparative, areas of related work. Obviously we're talking about programmer productivity goals. Natural language tools, language programming tools are obviously a comparable area of use. Snippet searching, and then of recent OpenAI and AI pair programming. So let's talk a little bit about how these compare to other activities in particularly in the natural programming and in the OpenAI area. What have people done in natural language programming? SemiNatural Language is one tool that has had some past investigation. It is very pseudocode-like, and it generates C. And you can see over here, right? It really looks like a program. Once again, it is not declarative. It is more like a traditional program, and doesn't really simplify things. The other area, the other example that people frequently refer to is literate programming, and it combines programming language with documentation, which in fact makes it more verbose, makes it more programs longer and more to them, and in fact really was not intended to improve productivity, but to improve documentation. So trying to achieve something different than what we are. And then natural Java is another past example. And once again, this is very similar to some of the things that are going on right now with software-based pairs programming, where you put in a particular task and it generates some Java code. So essentially, it's a tool for the nitty-gritty of creating a program, helping you with your syntax. And then, of recent, OpenAI, ChatGPT, GitHub, Copilot are something that always comes up when you start talking in this area. They are all based on OpenAI. They provide, you provide instructions in ChatGPT or Copilot or whichever of the tools you choose, provides textual results, and it can produce a program. So here is an interesting, one of the examples was a tip calculator, and every computer programming class, the student examples typically include tip calculators. So I told ChatGPT to create an iOS application for SwiftUI that accepts a bill amount, a tip percentage, and a number of people paying, and calculates the amount that person pays. And you'll see here it created a program. But you'll notice this is very different than the program that I created. And I went back and I added additional input here to try and make this look more like the other one. For example, they've put a slider here for the tip percentage, and I said no, I want to put in a number, but no matter what I did, it wouldn't change it. And I said, well, why is that? I said, well, these tools, the large language models, are really based on the language database that it starts with, and in this case, Copilot, for example, is based on GitHub, and in fact, if you start looking, there is actually a website out there that has a class called 100 Days of SwiftUI. And it winds up that all 15 solutions I received all had basically the code that comes from 100 days of SwiftUI. So essentially, OpenAI said, I want a tip calculator. OpenAI said, oh, I know what a tip calculator is. It's this thing over here that 15 different people posted to their GitHub sites, but it just so happens all 15 of them were taking the class 100 Days of SwiftUI. And so you really, these tools here have a lot of potential in the future, but at the moment they are really so dependent upon the source of their core data that they can be highly influenced by anomalies like this, where there is a website that generates all the examples on GitHub that are defined as a tip calculator. And also Copilot, for example, is really more, once again, like natural Java, where it expects you to give it line by line information. It says, I want to declare a variable, and it'll show you how to declare a variable. And it goes method by method. And so, these tools are valuable, but they're not the problem that we're trying to solve here. So in summary, our tests here on iOS-based applications show that we can generate more programs or equivalent programs with 1/4 to 1/7 the lines of code. It's easy to understand. These students and developers ranked it a 7 out of 10, 80% of the time, and easy to understand, compared to significantly lower numbers for Swift and SwiftUI. Error handling is built into the templates, and the survey results basically said that they found it to be a potentially very good application for quick development, prototypes, end user development. And that's my story. Questions?